If you are running an application on a single EC2 instance but want to scale it up, either because you have a high throughput of requests made to the EC2 instance, or you have a lot of users requesting to that instance causing your application to crash, then the application load balancer by AWS is exactly the thing that you need. An application load balancer acts as an intermediary between the users and the hosts running the application. It does so by creating a target group of hosts that are running the application and then routing the requests from these users to one of the available hosts in the target group. To get started with the AWS load balancer, we first need to create an instance. Let's go ahead and create a simple Ubuntu instance. Let's call it web server 1. Use Ubuntu as the image. T2 micro is fine. It's a small instance. And let's open it up to HTTP traffic. Let's hit launch. Alright, now our instance has successfully launched. Let's wait for it to come to running state. Right now it's running, so we can SSH into it. Now I'm going to speed run through this next part because it's just building a Python application on that instance. But it would work with any kind of application. It can be a React application, it can be a Ruby application, anything. Load balancer does not care what kind of application you are running. But you can slow down the video and look at what I'm doing if you are interested in building a Python application as well. Right, once the application is up and running, so we launch the application on port 80, then we can use the public IP address of our instance and then hit the application on port 80. And this is a single page application. Once we request it, we get this single page. The next part of using the AWS load balancer is to then take this application and then replicate it on multiple instances. So we'll use this instance and launch similar ones like it. And to do that, we can use the create image functionality. But before creating an image from it, we'd like to add a couple of things into it. So the first thing that we would add to our application is a way for us to be able to track the public IP. So while rendering the page, I will use the IP address of that instance and render it alongside the page. So let's create a variable for IP address. And then while rendering the template, we will create a variable for IP address over there and then pass it along. Now we'll update our HTML page as well. And in the HTML page, we would add another header, which will just show which application, rather which instance is catering to this particular request. So we can track that using this header tag. All right, now that the both of these things are done, we can now add the last thing, which is that we want to start this application up whenever the instance reboots. So we'll open our cron tab and add a reboot method here. So whenever the instance reboots, we want our Python application to start, and we'll write the logs from this application into a log file. Let's just call that app.log and then run that in the background. So that's the last thing that we want to add. Now we can go ahead and take this image, take this instance and create an image from it. Let's just call it web server image. And this just contains all the code for the application that we have just created. Rest of the things we can leave as is. Let's just create the image. It may take a while for the image to create, so be patient during this stage. So right now it's in pending state, so we'll wait for it to be available. Now that it's available, we can use this image to now launch more instances. So now I'm going to call it web server replica, and then, or rather let's just call it web server instance, and then keep rest of the things same, use the same key. It doesn't really matter if we allow HTTP traffic or not, but we can if we want to, or rather we can use the same security group that we used to launch the previous instance. And then let's say we already have one instance running, so let's just launch two more of these. So in total we'll have three such instances that are running that same single page application that we just built. So these two instances are up and running. So let's go back. Let's take one of these instances. Last thing we want to do now is to take all these three instances and create a target group from it. So sort of bundle them up in together into one application group. So to do that, we'll just go into the load balancing pane and select this target group option and then create a target group. Now we are creating a target group out of instances. So let's keep that as is. Let's name our target group like a simple web server target group, and then just use the default VPC. We are going to be routing HTTP traffic, but there is an option to route HTTP2 or gRPC traffic as well. Next up is the health check. So how does target group determine whether the host is healthy or not? Is it still able to serve traffic or not? So that's how, so it sends a request on the slash path, and then if it returns, it considers it healthy. Health threshold tells you how many health checks does it have to pass to be considered healthy. So I'm going to set that to 3. And interval tells you how often health checks are done. So I'm going to set that to 60 seconds. So every 60 seconds, health checks will be done, and it will expect status code 200. Next up, let's just add a name tag to it. So let's just add the same thing. Yeah, hyphens can't be in the name of target group, so let's just remove that. And that's pretty much it. Now you can click on create. Yeah, and now these three hosts are running. We want to add them to our target group, so we'll just select all three of them and then add them. Yeah, so all three of them are running and their health status is in pending state. We will add them to our target group, and now we can finally create our target group. Alright, once our target group is created, we can look at our targets. So all of them are in unused state right now because we have not created our load balancer and then route the traffic from the load balancer to this target group. So let's go ahead and now create the load balancer, which will then take the request from users and send it to this target group. So to create the load balancer, just open the load balancer plane. So we are running an application, so we'd be using the application load balancer, but there are other types of load balancers as well, like a network load balancer, which sort of gives you more customization options at network level. So let's just name our load balancer. This is going to be an internet facing load balancer, and we'd use this VPC. For the mappings, we want to use the same availability zone in which our instances are there. So our instance is in US East 1E, as we can see in the network pane of our instance. But when selecting, let's not select US West East 1E, we'll just select 1A and 1B. Let's see what happens if we don't select that particular availability zone. Next up is the security group. There's a default option, but let's create a new one from scratch. So I'm just going to call it my load balancer SG, and this will just allow the traffic from internet over HTTP port. So I'm going to select HTTP, and source it from anywhere. So that's 0000, and that just allows the HTTP traffic from internet onto our load balancer. And that's about it for the security group. We can now create this, and once it's created, we can now use this in our load balancer. So let's refresh that, load balancer SG. And next up, we need to attach our target groups. So we have our simple web server target group. So this load balancer will be routing the traffic from internet to that target group. So this is the summary. We have VPC 1A 1B that we are using and routing it to our simple web server target group over port 80. So now that we are ready, we will just create the load balancer. And once we go back and view it, so now it's in provisioning state. It takes a while for the load balancer to become active, but once it's active, you can now take the DNS name available and you can view your application. So if we just go ahead and open up and search it, and yes, so you get a 503 temporary unavailable error. So the load balancer isn't working properly, but if we request the actual instances, they seem to be working fine. Let's hit another instance. So let's pick up the first instance. Let's see if that's working. Yeah, so over there also we are able to access the application. What about the third one? The third one also seems to be working fine. So the problem is somewhere with our load balancer. So let's go to our target group and see if the 3 instances are getting used, and no, they are still in the unused state. And the reason for that is that we have not added the availability zone in which our instance is to our load balancer. So let's go ahead and add that in. So our instance is in US East 1E. So let's add that and save. The change may take a couple of seconds to happen. So once that is added, we can go back to our load balancer and refresh it once. So the load balancer is active. Let's see if the listeners are available now. So if we see, yeah, so all the instances are now in healthy states. So now we'll be able to access our application. Yeah, so the first time we hit the application, it's processed through this IP address. So that's our first host. Second time, it's another host. And third time, it's another host. So those are our 3 hosts that we have. And now as you request it again and again, it'll cycle through those 3 hosts one after the other. So it takes the request on the load balancer and then forwards it to one of the 3 hosts that we have. And it uses the round robin algorithm to figure out which host should get the next request. If you look at the attributes, you can see that the load balancing algorithm right now it's set to round robin, but AWS allows to add custom routing logic as well, which we shall see in the next video.